Good morning, everyone. I'm Marco Innocenti, and I study ethics of technology as a PhD student at the University of Milan and at the University Paris 1 Pantin-Sorbonne, while being a researcher for the Franco-Norwegian company BeFutures, developing new technological solutions for beekeeping. My speech proposes a new perspective on biomimicry, starting by questioning the intrinsically ethical aspects attributed to this innovation strategy along the lines of our attempts to redefine it. In particular, we will try to understand how this innovation strategy, widely used in research and development laboratories, can be reconceptualized to address a specific type of technology, namely AI-enabled robots in agriculture, from the perspective of supporting natural selection and keeping up with the rapid changes in the ecosystem during global warming. This study follows the trail of the so-called conceptual engineering, which is defined as a branch of philosophy concerned with the process of assessing and improving our concepts to achieve certain beneficial consequences. Whereas conceptual analysis has a descriptive character, conceptual engineering has a prescriptive one, indicating how a concept should be reformulated. The choice of the best conceptualization is based on certain practical interests and moral values. In this case, the reframing of biomimicry stems from the need to improve its concept in favor of its application in specific branches of ecological innovation. Janine Benyus' book Biomimicry, Innovation Inspired by Nature, paves the way for an innovation strategy that considers the natural system as inspiration rather than as a resource. We should probably start from the distinction between the terms biomimetics and biomimicry, whereas the term biomimetics represents the studies and imitation of nature's methods, mechanisms, and processes. Biomimicry intends to leverage this attitude to move from a condition of exploitation of nature to one of exploration. In other words, in contrast to biomimicry, approaches such as biomimetics and bionics do not necessarily focus on sustainable development, but instead concentrate on merely replicating innovative functions. For these reasons, biomimicry is surrounded by so-called biomimetic promises, namely by claim of intrinsic morality of this practice, as well as of extraordinary efficacy of mimicking nature. However, as we will see, following nature is neither sufficient nor necessary for being moral, and the same goes for being effective. Firstly, profit, sorry, firstly, profit, profit opportunities, to give an example, could lead designers and engineers to use this strategy for different purposes, thus making inspiration for nature insufficient for moral conduct. Secondly, there is nothing intrinsically positive or negative in the concept of nature, that is, nothing that indicates a moral value in acting in accordance with, as well in opposition to, nature. Nevertheless, there is an overall consensus in today's Western society that nature and naturalness are generally positive factors to be promoted, especially in the ecological awakening related to environmental issues. On the side of this supposed intrinsic performativity, one of the criticisms leveled at the concept of biomimicry underlines the aura it gives to the powers of adaptation in natural selection. This concept is central to biomimetic design, since it aims to mimic those traits perfected over millions of years of adaptation. In this framework, nature is seen as some is a some 4 million years R&D lab that has solved many of the issues we are coping with today. This approach has been criticized by Dominic Drians, who proposes an evomimetic approach to consider the different constraints that steer the adaptation pathway toward suboptimal solutions. Common's idea of evolutionary theory proved to be erroneous and misleading since they do not take proper account of factors other than natural selection, such as bioplan limits, drift phenomena, or the interdependence of organism traits, which are often isolated in biomimicry. Moreover, another reason for that is the absence of necessity of an optimal solution to increase individual fitness. When biologists engage with an overview of the different phenotypes ideally conceivable to improve the fitness of a species in its habitat, then many of them have no match in actual population, although they are often more effective than those that are actually present in nature. Therefore, a limitation of the common biomimetic concept is that it abstracts all this direction precisely because they are not found in the natural world. This means that imitating nature is neither necessary nor sufficient to find optimal solutions for a given problem. At a time when changes in climate take place at an incomparably faster pace than in past, a perspective such as the evomimetic one can also highlight limits in the adaptive capacity of different species. Here, the pivotal element is the speed at which this process occurs, and many scientists have expressed doubts regarding whether most natural population will have the capacity to evolve fast enough to keep track with current climate change. This aspect has already been considered in many recent agricultural innovations, which may come into play to mitigate its consequences. In fact, several biotechnological approaches in the agri-tech sector represent an attempt to compensate for the slowness of natural adaptation in the face of abrupt climate changes. Nevertheless, as the evomimetic critic shows, despite the urgency with which this emergency needs to be tackled, the concept of biomimicry does not prove to be suitable to fit into this type of innovation in agriculture and stimulate it into new direction. Even its evomimetic reconceptualization, however, is not enough because it keeps intact its approach to nature as a model and to human world as a field of application without an explicit return to nature that may lead to hybrid results. To cope with that, we will explore in the next section of this speech the leading contemporary philosophical currents devoted to technological innovation, particularly those related to its analysis from an ethical perspective. One of the leading current of analysis connected today with the uses of technology ethics is the postphenomenological school of thought, founded in the United States by Donaidi. This current intends to explore the ontological disclosure provided by the different technologies, whose plural declension should be emphasized. This plurality of technology, in fact, is intended to contrast with the Heideggerian view of technology, since, according to Donaidi, the elevation to technology with a capital T emasculates Heidegger's philosophy of technology from making any nuanced conclusion about particular technologies without capitals, because everything stands under the revealing power of the often framed standing reserve. Although many philosophers in the field of responsible innovation are following this empirical school of thought focused on specific technologies. Others criticize this point of view from an ontological and existentialist perspective. Critics of this phenomenological approach complain about insensitivity to broader contexts. For example, the social and political context of human being with technology, thereby ignoring the impact of widespread technological innovation. It should be emphasized that the rehabilitation of an ontological dimension in the philosophy of technology is also linked to the popularization of the concept of the Anthropocene. This latter concept, in fact, requires a more comprehensive and whole-oriented philosophical approach to technology than the empirical one, without substituting the latter, but rather complementing it through a macroscopic perspective. Indeed, this planetary condition calls for redirecting our attention from a micro level to a macro level and from the empirical to the transcendental again. In Vincent Bloch's article entitled Earth and Technology Toward an Ecocentric Concept of Biomimetic Technologies in the Anthropocene, we find a perspective on biomimicry that proposes itself as a guiding light for its future developments. The point of view here exposed underlines the aspects that emerge once one compares this practice with the current conception of the Anthropocene. Bloch reformulates this latter in the terms of an ontological experience of a world of being in which human existence is included. It is the experience that we live on Earth and as Earth. At the same time, Earth's dynamics prove to be less and less controllable and increasingly unstable. From this point of view, he criticizes the anthropocentric orientation of a traditional formulation of biomimicry, which can be found in much of its literature. Instead, from an ecocentric perspective on biomimetics, emerges an openness of this concept toward an hybridization of technology and nature, which can form natural technological hybrids within the horizon of a common belonging to the Earth system. Finally, we will attempt to combine the evomimetic and the ecocentric conceptualization of biomimicry. We propose that the ecocentric perspective can implement the evomimetic one, perhaps still centered on imitating the physiological traits of natural species, in revealing the possibility of creating natural technological hybrids against the backdrop of the Anthropocene. Conversely, the evomimetic perspective adds an evolutionary dimension to these hybrids, suggesting that their development should be seen as an aid to other organisms or populations in their adaptation to the rapidly changing environmental conditions. Together, these two directions open the concept of biomimicry to the modification of natural traits relative to species from which a priori it was only taking inspiration. By preserving its imitative method, an ecocentric evomimetic biomimicry can engender in the research and development labs a sort of phenotypic recombination among species beyond the limits of natural adaptation by applying traits of one species to another one. Without delving into the possibilities offered by genetic engineering and the associated ethical consideration, we can think of natural technological hybrids developed in agriculture, particularly in beekeeping, by mimicking human characteristics. This is the case of AI-powered robots in agriculture, which could be included in the biomimicry field through this reframing of its concept. The feature imitated by this innovative technology and applied to another organism or population, for example, a colony of honeybees, is of course human intelligence. It is emulated in its ability to analyze the available data and autonomously formulate decisions on how to respond to unprecedented circumstances. As far as the meaning of artificial intelligence is concerned, whatever definition is given to it, the core concept of AI has continuously been to create machines that were capable of thinking like humans. This technology is also described as an artificial mimicry of tasks and functions that would otherwise require human intelligence. Moving on to its use in agriculture, literature devoted to the impact of the so-called digital revolution in beekeeping focuses on the use of AI in correlation with sensors and cameras to provide the beekeeper with more robust predictive data and or a more informed overview of the beekeeping of the bee colony Earth. However, in addition to AI software products, which process large amounts of data to aid farmers' decision making, there are also AI robots that work relatively autonomously on a farm, for instance, in harvesting fruits or spraying pesticides on fields. Therefore, other directions of using this technology in beekeeping are now foreseen, in partial independence of the beekeeper's activity. Indeed, research is making huge progresses in using AI to produce robotic hives that function with a certain degree of autonomy, adapting themselves to the activity of the swarm. As an example, since 2019, the European Union has been funding the so-called Hiveopolis project, which consists of building an autonomously running bio-hybrid system by embedding these technologies in beehives so as to improve the living conditions of the colony in the context of the new environmental challenges. In this way, just as we draw inspiration, for example, from the internal organization of the swarm intelligence, to achieve a biomimetic design of the interaction between cloud robots, biomimicry can also follow the opposite direction, applying it to colonies the technological imitation of human intelligence, namely the AI, by producing hives that can run autonomously and better adapt to climate change. Thank you very much for your attention.